Welcome to aminacademy.com. In physics, let us discuss about types of flow and Bernoulli's principle. Laminar flow is called streamline flow. That is type of fluid, gas or liquid flow in which the fluid travels smoothly or in regular paths. In contrast to turbulent flow in which the fluid undergoes irregular fluctuation and mixing. Here, look at this. In a pipeline, flow is smooth as well as layers are not intercrossing. So it's called a laminar flow. That is, this flow is smooth and not mixing layers. Turbulent flow is mixing layers and fluctuation of the layers. In fluid dynamics, a turbulent flow refers to an irregular flow in which eddies, swirls, and flow instabilities occur. It is governed by high momentum convection and low momentum diffusion. It is in contrast to the laminar region, which occurs when a fluid flow is parallel layer with no disturbance between the layers. Here, the turbulent flow, there is a disturbance in the layers, but in laminar flow, there is no disturbance. Here, this is swelling is a good example for turbulent flow. Next, we'll discuss about equation of continuity. Continuity equation shows that the material of the cross-sectional area of the pipe and the fluid rate at any particular point across the pipe is consistently constant. This material is equal to the volume of flow per second or simply the rate of flow. The continuity equation is represented as or equal AV equal to constant, means A is cross-sectional area, V is the velocity of the fluid, where R is the volume of flow rate, A is flow area, V is flow velocity. Then we can say continuity equation in general you can write A1 V1 equal A2 V2, it goes A3 V3 A4 V4 like that. And particular cross section, that a volume crossing the liquid is seen in continuous flow. It's called continuity equation. Bernoulli's principle. Bernoulli's principle is a key concept in fluid dynamics that relates pressure, speed, and heat. Bernoulli's principle states that an increase in the speed of fluid occurs simultaneously with a decrease in static pressure or a decrease in the fluid potential energy. Look at this. This pipe's cross section is continuously varying as well as the height, the datum is changing everywhere. And that here, look at here, the force F1 equal to P1 A1. Here pressure is P and delta X is the smaller distance. This delta V is the smaller volume. V is the volume. V1 is the velocity of the fluid at some cross sectional. Its velocity is continuously changing because of the cross sectional is changing. Now, the Bernoulli's principles can be derived from the principles of conservation of energy. This states that it is in a steady flow, the sum of all forms of energy in a fluid is the same at all points that are free of viscous forces. This requires that the sum of kinetic energy, potential energy, and internal energy remains constant. Now, we derive Bernoulli's equation. Here, work done in section 1 is, look at here, work done in section 1 we can write as first W1, which is equal P1 A1 V1 delta T. That work done by the fluid at section 2 is W2 equal P2 K2 V2 delta T. Therefore, the total work done on the fluid is W1 minus W2, which is equal P2 minus P1 delta V. Here, P1 delta T and A1 is considered as delta V. This part, this three part considered as delta V. Change in volume. Now, the part of this work goes into changing the kinetic energy of the fluid, and part goes into changing the potential, gravitational potential energy. This work done partly goes to kinetic energy of the fluid and part goes to changing the gravitational potential. If the fluid density is rho, then change in mass delta m equal rho a1 v1 delta t, which is equal to rho dv1. This is volume. A1 v1 in delta t is v1. Then change in gravitational potential energy is dv du equal rho g dv h2 minus h1. This atom's height difference. Now, change in kinetic energy, we know that half rho dv v2 squared minus v1 squared. We know that v2 is the velocity of the second section, v1 is the velocity of the first section. Now, by work energy theorem, we can say p2 minus p1 dv, that is here, p2 minus p1 dv, which is equal half rho dv v2 squared minus v1 squared plus rho g dv h2 minus h1. Those given these two things, this du plus dk. By work energy theorem, we can say p2 minus p1 dv equal to half rho dv v2 squared minus v1 squared plus rho g dv h2 minus h1. Here, this expression, you have to divide this expression by dv. Here dv is there, here dv, here dv. If you divide throughout dv, we can get p2 minus p1 equal half rho v2 squared minus v1 squared plus rho g h2 minus h1. We rearrange the above terms. One side is first part, that is 1 p1 half rho v1 squared plus rho g h1. That is opening the bracket and collecting one part one side and second part other side. That is equal p1 plus half rho v1 squared plus rho g h1 equal p2 plus half rho v2 squared plus rho g h2. This is a Bernoulli's equation. In further simplification, we can write p plus half rho v squared plus rho g h equal to constant. Generally, you can write the Bernoulli's equation is pressure plus, that is P plus half rho v squared plus rho g h equal to constant. So far, we have done the derivation of Bernoulli's equation and its explanation, as well as continuity equation and types of flow, that is turbulent flow, laminar flow, like that. We have done. Please subscribe our YouTube channel.